How we doing? A slow start to a Friday. And I don't know if what the weather's like where you are, but it snowed and iced here. We had a winter storm warning here last night because of the ice, which, given that we weren't going to go drive anywhere, not really a big deal for us. But it's weird after the warm weather having snow outside. So, yeah, it was a good answer. And it's not pretty snow. Like it's, not quite enough to completely cover the grass, so it doesn't really look like nice. And it's, icy, crunchy, not sort of pretty soft. It's, yeah, not the best kind of snow to have. But there you are. Is it snowing a lot, Isabel, or is it snowing a little bit? Because of course you're in a totally different place than us. Okay, so let's go ahead and start. Hi, everybody. Um, so the big announcements are posted the exam. We'll run through that today and see if people have questions. I'm also happy to spend basically as much of Monday and Wednesday in class answering questions as take is makes sense. So don't be shy about asking questions. Remember that there are not sort of official office hours in the way that there used to be, but I have all these appointment slots. I'll post a link to those too. And I would certainly encourage people to grab an appointment slot. Oops, that did not work. What did I do here? Oh, I got like some fraction of the link. Oops. That's better. So definitely, start early and sign up for a slot. Also, feel free to post questions on Slack if they're or Canvas, but if they're general sort of questions, feel free to put them in a general sort of place where everybody can see them. If they're like, is this correct? Then I would probably do it in a direct message or an email. Having a photograph or some indication of what you actually have is really useful. It makes it a lot easier to provide specific feedback. So I got to here and then I was stuck, or I wasn't sure how to apply this rule in this place. Sort of the more concrete the questions are, the easier it is for me to provide useful help. So that's out. That's due a week, due Thursday. So 6 days and a bit from now, Thursday night. And then I also, and we'll go over this today too, I had a bunch of late questions about the assignment that was originally due 3 minutes ago. And it was clear that there were a number of people that had significant confusions. And I decided it might help to post some examples on Canvas. And I've posted a link in the chat here. And I thought we'd go over those today and see if that might help people that were having trouble with some of those assignments. Because there were some questions that suggested some people were, well, quite a few people were fairly far off the mark there. If you've already submitted and then after this you're like, oh yeah, I should totally change some things, feel free to just submit again, and that'll be fine, no problem. And so that's now been moved to 10 p.m. tonight. Let me know if that's an issue for people. Okay, so questions about any of that? Going. Gone. Okay, so let's first walk through the exam and then we'll talk about some of the translation stuff. And I suspect a lot of people haven't even had a chance to look at the exam. That's fine. But but I wanted to sort of walk through it and see if people have questions as we go. So, so second exam, so it's PDF that I've posted. Let me know if for some reason you're having trouble finding or reading the PDF, because that would really be bad. So there's 10 problems on the exam, 0 through 9. You know, because we're doing this as a take-home exam, obviously trusting everybody to be grown-ups and do the right thing. Main piece is that if you got questions, I'm the only person you're supposed to ask questions of, unlike on the homework where I'm totally fine if you talk to lots of other people in the class about things. On the homework, you know, I'm on the exam, I'm the person you should talk to. I realize that there's a lot of you and only so many hours of my life that are available between now and when the thing's due. If you're having trouble making contact or getting, you know, feedback from me, definitely, you know, yell and raise a red flag and stuff, because I don't want that to be a limiting factor for folks. The first section is on identities. This is actually very similar to a quiz earlier. So there are 4 quantifications, and your job is to say what the value of each of those quantifications is, and they all have a specific, clear value, and then you get to explain why they have the value that they have. So, actually, and I should pause for a second. Questions about anything so far? I get excited, and I just race on.
So in A, it says you may not use your notes.
Oh, really? Oh,
You
well,
can
that's
use your
just,
notes.
oh, I did, yes. Copy and paste from before. So ignore that. I'll update this and repost a PDF that doesn't say that, because you, as I say down here, it's fine if you use your notes, just not anybody else's. So yeah, you should be able to use your notes here. It would be kind of ludicrous to expect you to spend a week and not touch your notes, especially since you're doing homework and there are other classes. So yes, you may totally use your notes. My bad for not catching that needed to be updated. So thank you for catching that, Justin. Big thumbs up for you. Sorry about that. Other corrections, comments, suggestions? Going. Okay, then there's a couple of chapter 3 problems. One's a fairly simple one, exercise 3.43, to prove a simple theorem about implication. And then problem 2 is to prove, well, it's a slightly odd problem in that you're proving 376E, weakening and strengthening, but you're not doing it in the way you would have done it normally. You actually are asked to first use 385B replaced with true as the first step. And so that's in some ways the hard part of the problem. If you've got questions about how to apply 385B here, you should definitely ask those, because that's in some ways the crux of the problem. Once you've done that, then it's all just kind of simple-ish mechanical simplifications, and then boom, you're all done. I mean, several steps of simplification, because using 385B makes it sort of expands the problem out in a number of ways. But it's the 385B that's the hard part. So definitely try that. Try that early. Ask questions, and we can try to make sure you're headed in the right direction there. Questions about chapter 3 parts?
I have a question.
Yes.
So for number 4, or no, never mind. Number 2.
Yes.
Since we're using 3.85b here,
Mm-hmm.
would we be able to use anything before 3.85b or just before
Good question.
3.76d?
Right. So normally we would only be able to use things before 376E. So using 385B would be cheating. We're explicitly told to do it here in this problem, so it makes it okay. And then Kyle's question is, what about the things between 376E and 385B? Are they also fair game? You don't need them. Like once you apply 385B, everything after that is pretty straightforward, smaller number stuff. So you shouldn't need anything between 376E and 385B. I haven't really looked at all of those and thought about whether any of them would be useful. So let me say, for the moment, if you find something between 376E and 385B that you want to use, check with me first. I don't think you should need anything there, but if you find something that you're like, oh, that would just be so beautiful to use, ask me before you just go ahead and do it. Does that seem reasonable?
Yep.
Cool. Other questions? Good question, Kyle. Oh, and I think, just as a heads up, I think technically I'm not actually supposed to use your names. I'm keep doing it because it's habit. But I think because I'm recording this and I post the recordings, you're not, yeah. In big classes, people are not supposed to know each other's names, is apparently officially the rule. So if I use your name in the recording, technically I'm being bad. So apologies to the person whose name I just used. I find that whole thing kind of weird, but there we are. Okay, so section E, chapter 5. So there's a knights and knaves problem. So we have three inhabitants, Pat, Bill, and Sue. Pat tells you that Bill is a knave. Sue tells you only a knave would say that Bill is a knave. And that's the one that people often have trouble translating, is Sue's statement. If you aren't sure, feel free to, like that would be a great thing to just like plop on Slack, be like in a direct message, Nick, here's my translation for Sue's statement. Is that correct? And I could be like, yes, or no, you've missed something. And so if you're worried about that, that would be a good thing to check in on. And then Bill claims that Pat and Sue are the same. So I think Pat's statement and Bill's statement are pretty straightforward. I think it's Sue's statement that tends to cause people some confusion. So yeah, let me know if you got any questions about that. And then there's a circuit problem where you have a specification and you get to draw the circuit that specifies. And so here there are two outputs, S and Z, and three inputs, P, Q, and R. And this and is just saying it's not an and in the sense of an and gate. It's an and in the sense of, we have two parts to the specification, the one that says what S is in terms of the inputs and the other that says what Z is in terms of the inputs. So that's similar to a source of confusion in exercise 515 that we had on a homework. And then also there's an implies here, and there is no implication gate. We don't have one. So you're going to have to use a chapter 3 rule to rewrite this implication into something that we do have gates for, basically and, or, and not. So look at the possible rules for rewriting implication and see which one you think would make sense as a way to rewrite that implication into something with gates. So questions about the chapter 5 stuff? Okay. Oh. Chapter 8. So there's a couple of chapter 8 problems. The first is 8.6D, so that's a split off term. similar to what was on the homework. And then problem 6 is not in the book, but it's similar to the problem from the end of the problems in chapter 8 that we did on a homework. It's quite similar to that, actually a little simpler, but it's quite similar to that problem. Those two chapter 8 problems, questions about either of those?
I guess I have a question. So
Sure.
There's no so there's no proof numbers or theorem numbers next to those two.
Correct, because neither of them is a theorem in the book. So the problem 5 is just a statement that is, and it's in exercise 8.6D. I mean, that's exactly taken from the exercise, but there's no theorem. That doesn't match a theorem. And problem 6, I just made up. So it's similar to 8.7A, but not exactly the same, because you did 8.7A as a homework problem. So I don't know if that, I'm not sure I answered the right question. Excuse me.
No, you did. I don't know what happened there.
Okay, no, that's fine. All good. Other questions about chapter 8? Okie dokie. And then there's a few problems from chapter 9. So there's a translation problem because everybody loves those. You're having such a fun time with those. So you're supposed to translate 25 is the largest integer square less than 40. Okay. And we'll talk about translation problems for probably much, if not all, of the rest of class today. So hopefully that will help prep people some, but obviously come back and ask questions if you get to that and you're like, I don't know what to do with this. And then problems 8 and 9 are both proofs from chapter 9. So exercise 9.8 is to prove body weakening, strengthening 9/11. And problem 9 is exercise 9.15, which is an existential trading rule 9.19. So that's about the same length as the exam that I was probably, or a variation of the exam that I was probably going to use as the in-class exam. So this is not, I didn't make this a bunch longer or anything like that. Hopefully it will be of a reasonable length. I would encourage you to start it early if possible. I mean, I know people's lives are kind of crazy, but like if you could spend an hour on it today or a couple of hours over the weekend, so that you can come to class Monday and have like a pile of questions, that would be awesome. And we could spend as much of class on Monday answering questions as there are questions, basically. So any questions about the exam? Either about the questions, about the process, about anything?
Could I ask a question about the previous homework assignments? Sure. Do you know, or do you have like a guess for when the remaining ones will be graded?
That is a great question. We are going to try to get as much back to you before the exam is due as possible, because it would be useful for you to have that feedback.
Right.
So I have a stack from before break that are the translation problems that were turned in before break. I was going to do those over break, and break turned into converting everything to online. So I did not get those done. So they're sitting right over there looking at me with sort of a little guilt cloud sort of look. We'll try to do those this weekend, so you get those back. The TA is going to try to get the stuff you turned in Monday over the weekend. The stuff you're turning in today, I'd like to try to do that over the weekend, but I don't know for sure that that'll happen. So that the stuff you're turning in today, that's the translation from English to logic, I'm less convinced that you'll get that back in time to be useful, but I'm hoping the other two will come back in time to be helpful to you. We'll see how it goes, but that's the goal if we can make it happen. Does that make sense?
Yep.
Good question. Any other questions? Okay, then let us rock on to some of the translation stuff, because I do think that's been confusing in the past. It's been confusing this semester. I think it continues to be confusing. Let me first just share, there is this Canvas page that I posted last night, or yesterday afternoon, actually, so 4:25 in the afternoon. And it has 3 examples that are similar to 9.29a, 9.29g, and 9.29k, which are 3 problems that people have been having trouble with. And so I sort of tried to walk through these in some detail. And I will basically repeat that today for at least some of them, depending on what would be useful. And then we'll sort of see where we end up and how much time that takes up. And then depending on that, we'll maybe move on to some other things, but I wouldn't be surprised if this takes up the whole day. So I'm actually, my plan now is to switch to the whiteboard and basically walk through these examples. So does anybody have any like general questions before I flip to the whiteboard and we actually like draw and talk and stuff? Okay, then I'm going to stop sharing that and I'm going to start sharing a whiteboard. Okay, so 9.2a really tends to mess with people's heads. And people have a tendency to want to quantify over the wrong things on that problem and on some of the other problems, but this is one where it definitely comes up as an issue. So the problem, the problem on the homework is the natural number 1 is the only natural number that is smaller than a positive integer and divides p. And the thing that I think tends to mess people up there is the only part, that 1 is the only number that has a property. And people then start to quantify over the wrong things. So let's, as an example, let's consider the English statement. And I'm hoping that these will be pretty similar and give you sort of some fairly hefty hints on how to do the translations on the homework. If you're not clear on how my example connects to the homework problem, or if you feel like there's an important, complicated aspect to the homework problem that my example isn't capturing, definitely ask. But I'm hoping that these will help out. So I'm going to go with Sally is the only 1302 student living in city C. Okay. So we're saying Sally is the Oh, it should have said only. Is the only student in the class that lives in some city C. Okay. Now, an important part of this is that you would not quantify, do not quantify over Sally or C. Because those are values that are being specified kind of outside the statement and are being handed into us, right? And Sally's actually pretty straightforward. It makes sense. Like you wouldn't say, you know, for all Sally, right? Like that, what does that even mean? Or exists Sally? Because you don't quantify over a constant. It'd be like for all 7 or exists 7. Well, I mean, no, I mean, that doesn't really track linguistically. If you were in a conversation with a person and you said for all 7s, it'd be like, what do you mean? I mean, there's like just 7, or there exists a 7. Well, of course there does. It's 7. So we don't quantify over Sally. Now, we also don't quantify over C, and this is perhaps less obvious. But in a statement like this is meant to be a specific city C that is being handed to us from outside. Like if I replace this with Morris, right, then it would be pretty obvious that we don't quantify over it. Because, again, you wouldn't say for all Morris or there exists Morris, right? Morris is a constant. And this is actually meant to be a value that's coming in, and we don't quantify over that. It's, for us, it's a fixed value, okay? And so in the case of 9.29a, P, so 1 is kind of like Sally. It's a constant, we don't quantify over it. But also P is a constant, or at least a thing we don't quantify over, because it's coming in from the outside. This is like saying the natural number 1 is the only natural number that is smaller than the positive integer 7 and divides 7. Or the positive integer 13 and divides 13. It's a value that I'm providing as part of the statement. And so you don't quantify over it, you just use it. So C here is meant to be kind of like P in 9.29a. But this is frequently a source of confusion. So as we go through this, if you get to the end of this problem and you're like, I still don't understand that part, holler and we'll talk about it some more, because that is, I think, one of the most confusing pieces of this. Okay. Questions about any of the setup before we move on? Yes, I see that there is a chat thing. Let me go find the chat window. So there's a question about what do I mean by quantify? I mean, have a quantification for all Sally, or exist Sally, or for all C, or exist C. Okay, so in problem 9.2a, a lot of people had things like for all P or exists P. And you don't want to do that because P is being given to you as a value. So you don't quantify over it, you just take it as a value, okay? That might make more sense when we finish doing this problem, I don't know. Did that help some? Okay, cool. Then I'm going to, let's actually talk about sort of how we would do this. So when we say Sally is the only 1302 student living in City C, we're really sort of saying two things. So we're saying the first thing we're saying is Sally is a 1302 student living in City C. Okay. So this statement does say that. It says that Sally is a 1302 student living in City C. Okay. It also says no one else in 1302 lives in C. Okay. So there's these two things being said, that Sally has this property and no one else has that property. If I say, Sally's the only person who's 100 feet tall, I'm both saying that Sally is 100 feet tall, and I'm saying that nobody else is 100 feet tall, right? And so you really need both of those pieces to fully capture what's being said in that statement. And that's an important thing that I think often confuses people. Does anybody have a question about that? Are we okay with that? Okay, then let's rock on. So the first one is pretty straightforward because it's just a statement of a couple of things. So I'll have to make up some predicates. So I'll make up, oh, that really looks like a B, doesn't it? Let's fix that. So in 1302, Sally. So I've got to make up predicates that make sense for the problem. And so I'll just say in 1302 is a reasonable predicate. And I'll make up a lives in that says that Sally I can use to say that this person lives in that city. And so the first statement says in 1302 Sally and lives in Sally C. So Sally is in 1302 and Sally lives in City C. And I just invented these, right? And there's not a specific right answer there. You need something that's reasonable. And you might want to have a little English that explains what your predicates mean if it's not obvious. But if you name them pretty clearly, that might not be strictly necessary. Questions?
Yes. So for lives in City C, hypothetically, could you create a predicate that says lives in City C and only has one parameter, and that's Sally?
You certainly could. So as an alternative here, since all we seem to care about in this problem is City C, you could, as an alternative, say lives in City C and say Sally. What I have is perhaps a little more general in that you could put in whatever city you want here. But I don't have a problem with doing it this way. I think in terms of the 9.29a exercise, it sort of makes sense to think about it as because in 9.2a, there's a divides business. And so I think if you think of there being divides X, Y is true if X divides Y, i.e. Y is a multiple of X. Sorry, that got a little small. That's a useful thing to do in 9.29a. And so I was trying to have something that sort of paralleled that here in my example, but you're completely right. Lives in City C would work fine here. It's just not quite as general as my lives in. Notice I could have generalized this. This has 1302 sort of cooked in. So you could have, as an alternative, if you wanted to generalize this, you could say something like, in class, Sally, CSci 1302. And that would give you a more general version of this that could be used to say a broader range of things, which might be kind of useful, actually. One could argue that this more general one would be preferable in some sense to what I did. You know, there's a question of like solving the problem, and for solving the problem, we can be super specific. So your idea of lives in city C makes perfect sense. My in 1302 makes perfect sense. But if we want to think about how could we create a set of tools that would be more generally useful, then more general things like lives in or in class might be preferred. I'm not too worried about it. I'd be fine either way. Does that make sense? Questions about that?
Yes, thank you.
Cool. Any other questions? Coolio. Now, no one else in 1302 lives in city C. Now, when you've got a no one else, again, because of generalized De Morgan, any for all could be rewritten as an exists and vice versa. You just move some negations around. I see no one else and I see not exists. There does not exist somebody in 1302 that lives in city C. You could also see it as everyone in 1302 does not live in city C, and that would actually be totally fine. And generalized De Morgan says they're the same thing. But I'm going to do it as a not exists, because that's sort of what I see when I look at something like that. So I'm going to say there does not exist person P where, and I'm going to, as an example of something that I find very helpful when doing these, instead of trying to translate the whole thing at once, trying to translate it in pieces, which is part of what I did here by breaking it up into these two parts and then doing them separate. But I'm even going to do it more here. I'm going to say there is somebody, a person P, or there's not a person P, where P is in 1302. So this is just English still. And we'll have to convert it to logic. And P lives in city C. So we're saying there is no person P where P lives in 1302 and P lives in city C. And again, because of trading, I could use these as range and body. I could join them together in the body and say P in 1302 and P lives in city C. There's a bunch of right answers here because trading says there's a bunch of right answers here. But I find this one makes sense to me, so I'm going to go with it. But if you're like, I have questions about that, or I think another way would make more sense, absolutely speak up. So questions about what I've done before we then tidy up the details. Coolio. Then I'm just going to say, I'm going to sort of formalize these pieces. So this becomes, and I'm going to actually use equivalence. That's probably a bit of a stretch because these things aren't precise enough to be saying equivalence things about. But I'm going to transform that into, well, how do we say P is in 1302? We've got our little predicate in 1302, P. And how do we say P lives in city C? We have this lives in predicate, lives in P C. And so that would be a plausible translation of the no one else lives in C. there is not somebody in 1302 that lives in C. Oh, actually, this is not correct. The no one else is the else part I left out. And this is really important here. We need and P not equal to Sally to go there. Because without it, this is in fact not true. Oops, sorry. Because Sally is in 1302 and lives in City C. That was the whole point of this part. And so if we leave this out, then this will never be true, because there will always be a P that makes this true, and that's Sally. And so since the exist will always be true, the negation will always be false. So that would be bad. So we need to say that there is a person that is not Sally and who is in 1302 who lives in City C. So the and not Sally is really, really important. So in 9.29a, where we say 1 is the only natural number that has some property, if you have like j as your quantified variable, you need to make sure you say j is not equal to 1, because 1 does have the property, and you're saying nothing else has the property. So you need to say everything but 1. So j not equal to 1 is going to be an important part of the way you frame that problem. So are there questions about this translation here, which is the second part up here? Going. So then to put it all together, it would be, we would need to have in 1302 Sally and lives in Sally C, and this whole not exist thing. So there is not a person P that is in 1302 and different from Sally that lives in City C. Sorry, to move a window a little bit on my end. Lives in PC. And that would be the full translation for 9.2a. So Sally has these properties. she's in 1302 and she lives in C, and there is no one else that is different from Sally and is in 1302 that also lives in C. So that's a lot. Questions? Going. Gone. Okay, so we've got 20 minutes left. I'm not 100% convinced we'd get through both my example for G and my example for K. So G was the real number I is the largest real solution of the equation Fi equals I plus 1. And K is no integer is larger than all others. I think my inclination would be to do G, because I think that's just a little more confusing. But if there's anybody that's like, no, I totally get G, but K confuses me, I'd really rather you talk about K, now would be a great time to say that. Questions? Suggestions? Okay, so we'll move on to G, and if there's time, we'll do K as well, but I'm just not convinced there's going to be time. So So G is real number I is the largest real solution of the equation Fi equals I plus 1. So first thing is that this business about solution to the equation frequently muddles people. And all that means is that I has the property that Fi equals I plus 1. So that's all that that's saying. It's not saying anything more profound than that. Yeah, don't sweat that. So I'm going to actually do, as a similar example, integer p is the largest prime less than 100. Okay. Now here again, we have two things being said. One is that P is prime and P is less than 100. So we're saying P has these properties. It's a prime and it's less than 100. And we're also saying that P is the largest one, which means there's no other integer bigger than P that is also prime. So no other integer is bigger than P and prime. Okay. So we're making, it's similar to the previous one where we said Sally was in 1302 and lived in city C. We're saying P is prime and P is less than 100. So we're saying the things that are true about P. And we're saying that nobody else is bigger than P and also prime.
Don't you have to say and less than 100?
Yes, correct. Good catch. That's an important piece. Well done. Yeah, so nobody else is bigger than P and less than 100 and prime. Okay. And again, we're not quantifying over P here. P, this is a statement about P. So we don't get to quantify over P. We're saying things about P. So we can say P is prime and P is less than 100, but the quantification is about things other than P. So we're saying there are other values. Well, in this case, we're saying there are not other values that are bigger than P and less than 100 and prime. And that's a statement about those other values, not a statement about P. Okay. Questions about that? Okay. So then let's translate. So P is prime. I'm just going to invent a predicate prime. And then P is less than 100. Well, I'd actually done that. So that part's pretty straightforward. Questions about that? Okay. Now, the next part, no other integer. Again, I see that as there does not exist. There is no other integer. There does not exist an integer. So I'm going to say there does not exist an integer. I have to come up with a name now. I'll say I can say that it's an integer by saying it's of type Z. And again, I'm going to do this in pieces, so I won't try to translate the whole thing at once. I'll say there's no other integer that, I is bigger than P, so P less than I and less than 100. Oh, I sort of did that whole range, didn't I? So, and then I guess that prime I. So I said I was going to do it in steps, and I ended up doing the whole thing in one go. So bad me. but I'm saying that there is no I that is bigger than P and less than 100, and I is prime. So I think what I kind of intended was to write something more like this. I bigger than P and less than 100. And I is prime. So I think that was kind of what was in my brain as my intent, but I just was like, oh, I hate writing English, must be math, and then just convert all this to math on the fly. So that, kind of was done. That turned out to be very fast. Questions about that? That ended up like just, I flew through that really quickly, and I feel like that may not be very helpful. But it does mean we have time for K.
I have a question.
Yeah, go for it.
So can we just make up whatever like predicate we want for
Sure.
like, do you have anything? Yeah, okay.
Yeah, pretty much. I mean, unless it explicitly says you can't, like, if it's one of these problems where it's like, don't use even or odd, then you're like, oh, fine, I'll have to use the exist thing that we talked about. But, unless there's some explicit statement that you can't do that, yeah, feel free to make up predicates. Like if there's words like, prime in the problem, feel free to like invent a predicate prime. I mean, I don't think that applies to any of the problems that we're talking about today, except for possibly the divides business on 9.29a. If you want to invent a predicate divides and just pretend it exists, I'm okay with that. But G and K don't really have properties like that. So
I guess I get confused as to how you would say like I is a solution to an equation.
So that's just I is a solution to f of I equals I plus 1. That's just f of I equals I plus 1. That's all that is. Or if you want, you could think of it as equivale true. And notice that we could also say X is a solution to f of I equals I plus 1. And that would be essentially, we like put in X for I everywhere. Okay. So that's all you're saying, is that if you're saying something is a solution to an equation like this, you would be putting in that for all the arguments and saying that that's true. That's all that means. And similarly, if we wanted to say 3 times W divided by Y is a solution to f dot I equals I plus 1. That would just be f of 3W over Y equals 3W over Y plus 1. That's all that's saying. Does that help a little? Some? None?
Yeah, that helps.
Okay. Other questions about this one? Now it's worth pointing out that actually I'm looking here at what I posted, and I posted a totally different answer because, you know, life is complicated and English is weird. They're provably equivalent through some trading rules, but what I said in the notes that I posted on Canvas is there does not exist. So for starters, I use J instead of I, but that's just a name thing. And dummy renaming would let us swap between them. And then I said prime J and J less than 100, and then J greater than P. And so all the pieces are there. J is prime, I is prime, I is less than 100, J is less than 100, I is greater than P, J is greater than P. So they're all here together, and it's still a not exists. So these are provably the same through some trading rules, but I just organized them differently. And if you had turned in, like if this had been a problem, you know, I would accept either one of these or any of a variety of combinations as correct answers because they would be correct, right? And it's really sort of a matter of what you choose to focus on in the statement. So, yeah, however you want to do it. Questions about this problem? Then let's quit. Oh, go ahead. Somebody?
So then is the final answer prime.p and p less than 100 and not exists?
Correct. Yes.
Okay.
Yes, that's a good point. So the final answer would be these pieces and some not exist, whichever not exist makes you happy. So it'd be the whole thing. Cool. Questions? So we have 8 minutes. Let's do a little bit on K. I don't know how far we'll get, but we'll give it a shot. So K says no integer is larger than all others. So my fairly direct substitute, because I struggled to think of a good example here. So this is a version of, you know, I love all my children equally. So no one in 1302 is better than everyone else. In 1302. And I'm going to assume here some better predicate xy that says x is better than y. How we're measuring better, I mean, none of this makes any damn sense. So don't, you know, get too exercised about the social implications of the statements being made here. Again, it seems to me that this is a not exist. No one suggests to me that we're saying that there is not a person that is in 1302 and then what's the body? The body is P is better than everyone else. Okay. Now, this will just have an in 1302 again to handle that. So that's pretty straightforward. Now, this part, we're saying P is better than everyone else in 1302. So we're making a statement about every person in 1302, that they all have some relationship with P, okay? So that suggests to me that we have a for all here. So we have a for all, say, Q, and we're saying something about everybody that's in 1302. And here again, we also need that Q not equal to P, because it's everyone else. We're saying something about everyone else. We're not saying something about P. So we have to say Q is in 1302 and Q is different from P to make it clear that we're talking about the people that aren't P in the class. And then P is better than Q. Okay. So we're saying that for every person in the class, so for every person that is in 1302 and different from P, P is better than Q. And so now we can translate those pieces further. So the first part's all still the same. And here we have for all Q in 1302 Q. So that's this part here. And Q not equal to P. That's that part there. And then here we'll use our better thing. Better P, Q. Okay. So we're saying there is no person P in 1302 such that for everyone Q who's in 1302 and different from P, P is better than Q. And I think for something like this, doing it in pieces really helps. Like trying to do the whole thing at once is a little overwhelming. But if you sort of break it up into parts, like I think it's not necessarily obvious that you would want a not exist with a for all inside. But if you sort of break it up in pieces, you're like, okay, it's no one, so it's not exists. And then the body is P is better than everyone else. And then you translate that and you're like, oh, that's a for all, right? And by doing it in parts, these things come up more naturally, or it's less confusing as to why they come up. But if you just try to take the whole thing and translate it all in one step, it's a lot to do. So breaking it up into parts and handling the parts separately, I think helps. I don't know. Questions about that one? Or about anything we've done today, or about the exam? We got basically 2 minutes left. So questions about anything? So there's been a question about whether I can upload today's lecture early today. I think I actually can. Often, like no one signed up for the next 2 slots. So there were 2 slots right after this. If I'd had people lined up for those, then that would really slow things down. But since nobody signed up for those slots, I can probably get this done in half an hour-ish to 45 minutes. It takes a while to finish encoding the video on my computer, and then I have to upload it to YouTube, and then YouTube has to process it. So there's some delay that I can't make go away. It's not just about like, am I on top of my game? It's sort of like, I got to wait for computers to do their thing. But I think within half an hour to 45 minutes, I can have this up. So it'll be there if you want to, if that's useful to you in doing or redoing and resubmitting the homework. Any other questions? Okay, well, have an awesome weekend. If you're in a place where it snowed, enjoy the snow or stay inside and have hot chocolate. I don't know. And at least here it will warm up again in a few days and start to be spring again. I will see everybody Monday. Definitely ask questions if you be prepared to ask questions Monday or ask questions over the weekend. And I will see what I can do. So thanks a lot, and we'll talk to you all later.